Hey guys, this is Matt. So today we're going to be talking about the columnar transpositions, and this is a form of encryption. And this is part of these cryptography on simple ciphers, where we actually look at the um, mathematics behind these simple ciphers. This is going to be a little different because this one actually features a Scytale, which we'll be going into what that is here in just a moment. So, of course, we start with just a little bit of history. And back, well, actually in 2018, the movie Red Sparrow came out with Jennifer Lawrence and Joel Edgerton, who played Nate. And in one scene, Nate receives a call from the CIA where an encrypted message he writes down on a piece of paper and then wraps it around a pencil, and then he looks at the message and he can see it clearly. Well, that's using a Scytale where you actually use a cipher stick to actually wrap the message around, and that uses columnar transpositions. So, what that, of course, Hollywood did not invent this cipher. This was actually used well before that, back in the mid 3rd century by Apollonius, I believe, with his Scytale. And looking at what this actually is, um, this is it's a very unique cipher, and as you can see, it does take out all of the spaces. We do not use spaces with this columnar transposition. So we go through and we pick an original message. You can pick whatever you want. And so we go through a testing string, sounded good to me. Now you then need to choose a column number. Now the column number does need to meet certain criteria. I chose the number 3. So first we need to actually go through and find how long the string is so we can check to make sure does this fit. And we can see that it's 14. It is obviously lower than the number 14 is higher than 3. So it will work. So we take it and we go, all right, we start with the number 1, or if we're looking at it in programming standards, 0, 0. So x is 0, y is 0 on the matrix. And then it's first one, second, third. Once we hit the end or hit the max of our column number, we then drop down to the next row. And then you continue until you've got no more characters left. And because it's the number 15, 5 times 3 will be 15, so that's one more than our string length, so we're going to just have a null character there, which is fine. It doesn't matter because this won't be added into the very end anyway. So we're then going to run down those columns. So we start at the top and go down, and then start up. Once we've reached the end of this, start at the next one and then go down, and then write them out accordingly. So then we drop down and we need to join these columns, the column text together, or append it to the previous one, and then we get our full text. Now, you can work this out and look at, let's see, this would be 6 over, so every 6 1 will be the very next. Or you can just wrap it around a cipher stick and you'll be able to see this message out very clearly. Given the diameter of the stick, of course, you have to keep that in mind. This number may change based off of that number. So, however, this is still in clear text. So let's use a little more complicated string so we can actually see this. So number 5, Um, all right, and we're going to use, let's use the number 3, why not? So we can see that we went through, it printed out, and then it gave me this R, which this is used, it's just basically just some garbage left over from previous runs that does not actually show up in our final encrypted readout. Now this is still in clear text, so please keep that in mind. You can mathematically break this down, and you would take the full size of the string, of course minus the spaces, then you would go through and then take the column number, which we had has 3, and then you would divide them. Now this does have a modulus of 2 because we've got 2 extra here, and then so it would have the extra 1, so then you would have to add that, and that is your easiest way would just be to take a cipher stick and wrap it around. But you can do it that way, but you would just have to continue to have to count I and then S, and you just keep on going. So let's do another one that's unencrypted. We can, well, unencrypted as far as our text reading to actually be printed out is not encrypted. This is a form of encryption because you cannot read it clear text and just as is. So I was looking through on Wikipedia and found another example. And they have I am hurt very badly, help, and they use the number 5 as the column. So this does read out, and obviously we cannot read it just as is, so we take it, wrap it around, and then you would be able to read it. So 1, 2, 3, 4, 5, 6, 7. So every 7th one will be the actual clear text going through. So we've seen what it looks like when it's printed out just in clear text. What if we add one layer of encryption? Because we don't want somebody to intercept this and see it just as clear text. Let's actually run it through and run just an encrypted column transpositions for the Scytales. So we're going to go through and we can use all right, so this is the testing string, and let's use a smaller number. Let's use number 2. Now, it prompts us to actually offset the number. Well, this should look familiar from our Caesar cipher, where it prompted us to say what's the offset, because we're adding that onto the ASCII value or the ASCII decimal. So if, say, the number is 65, then you add 2, or sorry, the letter is capital A, which is 65, so we add 2, which would be 67, which would translate back to a capital C. So looking at this, let's use the number, I don't know, 8. So we can see that it went through, and this is our actual encrypted text, and it does have a layer of encryption, so it will be a lot tougher for the person or the hacker, the attacker, to actually break. However, it still is just a simple Caesar cipher, so you can go and it basically you just subtract the offset number and you're able to see it back in clear text. In our next video, we're actually going to go through and talk about the double columnar transpositions. And so this is a little more complicated once we get to that. But this one is fairly straightforward, where we actually go through and encrypt it this way. So that's all that I have for today. Thank you very much for your time. I really appreciate it. And full disclosure, I am not getting a kickback from Red Sparrow. I just thought that they did a good job with showing that this cipher. So just wanted to give props where props was due. If you have any questions on this cipher or any others, please let me know. Just put it in the comments below or shoot me a message. If you want to see more ciphers, let me know. I'll be happy to help. If you need help with any ciphers, then please let me know. I'll be more than happy to help where I can. So once again, thank you very much for your time. I really do appreciate it, and I hope this has been beneficial to you. So y'all have a good one, and I will talk to you later. Thank you.